As I understand, we've got audience members on the line from around Australia and across different segments of industry, from startups all the way through to large corporates and investors. So a really nice mix. And as Adam noted, we're talking about hydrogen. Now, many of you will know that hydrogen has been an incredibly live conversation lately, particularly in Australia, but also in East Asia and the EU. There are lots of different things pushing the hydrogen conversation. And a lot of us, I think, have felt like we spent the whole year or the second half of the year locked in various stages of lockdown talking about hydrogen, which has been so exciting. And the question has often been, which technologies and which applications are we likely to see hydrogen moving in first, and how is it likely to develop? And so, as Adam noted, you know, it's excellent. We've got a fantastic panel to discuss really the front edge of the hydrogen journey and also how that hydrogen conversation fits in with the whole system. So Adam mentioned we've got Andrew Clennett and Dan Zafir. And before, when we were sort of getting ready for this conversation, I asked, you know, are there any points that we'd like to talk about with those two organisations? And they both said varieties of the same thing, which is we are trying to help the commercial system commit and innovate in this transition and helping to deploy capital in the right direction. It's bigger than us. It's a much bigger problem than just an individual company or an individual technology, but we are really trying to get on the path and put our money where our mouth is, I think is something Andrew said. And I should say that also Sybil, she is a senior investment analyst at UniSuper, but she is responsible for thinking about all of these difficult long-run trends that relate to investment, climate change, new energy systems, human rights, whatever it happens to be. And she's also a member of the board of the Investor Group on Climate Change. So excellent group of people to have the conversation with. So I'm going to kick off. We'll sort of walk through the broader context and then go into, you know, some of the specific solutions that are evolving and the technologies that we've got represented here today. But firstly, Sybil, I might throw to you and just ask, you know, why are investors even discussing hydrogen, and how are you approaching the conversation?
Thanks, Zoe. Thanks, everyone. I think, like, most crucially, I think we're seeing huge amounts of ambition in order to meet the aims of the Paris Agreement to decarbonise our economy. While for many sectors, you know, we clearly see electrification and renewables as an easy solution, there are many applications where energy molecules are really important, and hydrogen looks like it has the potential to be a low carbon fuel for many industrial applications. Also has the potential to provide other benefits, such as a store of energy for renewable denominated grids, and also has the potential to be an export avenue to replace gas and coal and sort of our current resources that we're exporting. So there's lots of different ways that hydrogen has the potential to be a really interesting investment opportunity, a transition opportunity for companies as well. And so, you know, from our perspective, we're really interested at the moment to understand it better, understand the applications, and also so we're able to sort of better interrogate where we do have companies that are seeing this as an avenue for decarbonisation, to kind of be able to understand where and how those plans make sense, and whether or not they'll be successful.
Interesting. So one of the fantastic things about this mix of everyone we've got today is that we've got both ends of the conversation. And so, Dan, I might go to you, and Andrew, I'll come to you in a minute. And I'd love if you could tell us more about Xenogen and how Xenogen sort of fits into that system and what the vision is, just so that the audience sort of, I guess, understand where you're in the system a little bit more and how you fit into that conversation.
Definitely, for sure. And thanks very much, Zoe, and thanks, Sybil and Andrew and Adam. So Xenogen started out as a spin out from the University of New South Wales here in Sydney, the School of Chemistry, where we had developed a catalyst that improved the production efficiency of hydrogen. And so we, I suppose, started out as a very small research and development oriented business, and it was about commercializing essentially a widget or a component that was going to go into someone else's value chain or production line. At the time, hydrogen for mobility was still in its very early stages, and so we were looking at industrial gas production, and that market is squarely dominated by a few players in most of the global spaces. And so as Xenogen grew, we realized that we were not just a catalyst business, but we had the ability perhaps to do system integration or full deployments. And so we started looking at the grandest opportunities in hydrogen, and we really discovered that mobility is, it's essentially green fields today, and mobility has the ability to eclipse, the existing industrial hydrogen gas market. And that's not to say that we are, just, commercial mercenaries here looking for the best market opportunities. We're totally in love with mobility. We're all car enthusiasts. We drive EV cars. Actually don't own a car, but those of us in the team do drive EV cars, and so we're sold on the future of it. And we just thought, let's take our expertise and dive headfirst into this burgeoning opportunity. And so Xenogen morphed from a catalyst development business into essentially a hydrogen gas solutions provider in mobility, where we are fully integrated. So we don't just make the gas, we work with distribution technologies to move the gas around, and we obviously have dispensing technologies as well. And because the industry is nascent, in Australia here, the access to vehicles that will use hydrogen is reasonably limited. And so we have partnerships with major OEMs and hydrogen system integrators to be able to essentially fit out vehicles to match our generation systems, so that we provide an end-to-end solution for our customers. And just to cap it all off, right now we are squarely focused on the refuse collection space and other heavy specialist vehicles. Heavy vehicles make a fantastic case for using hydrogen as their fuel if you want to go electric. That's versus batteries and perhaps even versus diesel. And so of all of the different use cases in special and heavy vehicles, refuse collection vehicles are where we're headed first.
I'm going to come back to you on that, because it is a super interesting part of the space. So let's talk about trucks a little bit more in a moment. But before we do that, Andrew, I wanted to come to you and ask a similar question. That is, what is Harbinger? What are the projects, and how does it fit into this conversation about the direction that the economy is taking with respect to transition?
Yeah, so thanks, Zoe, and kia ora, everyone. Yeah, look, my background is I came from the energy space and the upstream conventional energy space. I worked at Woodside as a manager there. I ran Todd Energy's operations here in New Zealand, and started to see that we really needed to change and make this transition happen. But it is very difficult for those big companies because of their invested infrastructure and so on. So certainly identified the need to actually go out there and create the opportunity, but looking at where do we go? How do we get that kicker to go for the hydrogen to commercialise? Because it's going to be that commercialisation that will drive the transition. Simple as that. So we identified the markets, we identified the net back effect, where the price points are for the different applications. And it didn't take much looking and thinking and analysis to identify that mobility was a really good early one. An end game will be the volumes of export, the volumes of industrial feedstocks, absolutely big drivers, huge decarbonisation impacts. But where the commerciality will come from is going to be at that mobility space early. That's where we see. But we also need to manage and be part of all of those elements to really take the mobility, take the economies of scale we can create into these other sectors. So we've focused heavily on that, but we also have some projects that are looking at industrial feedstock as well, and the interplay between the two. The thing is, actually, hydrogen can interplay. It's an energy vector that can move between a mobility application to an industrial feedstock. So we're, for example, one of our core projects at the moment is an industrial project. We're building a fairly decent wind farm next to an ammonia facility, and it's a joint venture partnership with that ammonia manufacturer here in New Zealand, and we're making green ammonia from that. We're also running the plant with the wind, so it's a really interesting system play for hydrogen. So that That has also, though, driven some scale for our hydrogen production for the transport, so we can vector between the two and shift. At the same time, we're saying, well, where in the mobility sector is going to have the biggest impact? And as Dan's mentioned, it's in these applications that have got a high utilization, have got the more niche applications to start with, but with huge emissions impacts, actually. So we can align hydrogen commerciality with high emissions and high impact by going to the heavy transport sector, for example. So our second major project that we're working now is creating a refueling network for New Zealand to unlock those heavies. Now, we've got the advantage in New Zealand is that we are this finite country. It's that classic big enough to do it and small enough to do it, create this entire test bed. We looked at sort of hub-based pieces, but we realized, no, let's go for a network that create that scale and commerciality. So they're our two key projects, but we're all of this is about creating that scale, getting larger, getting the costs down, demonstrating that, and we can come back to how do we bring some of the incumbents along on that journey.
Absolutely, that's a right sort of topic for discussion. I'd love to get there. Sybil, I'm going to come to you and just, you know, transport's been raised a couple of times, and so has the question of where does hydrogen become viable first, and in what type of composition, you know, hubs versus networks, heavy transport versus border systems export versus local production. I'd be really interested to hear from you what are some of the debates or conversations or trade-offs that are happening in the investment space with respect to how do we do hydrogen and how do we expect green hydrogen, let's say, or sustainable hydrogen to evolve?
I think one of the challenges that we have at the moment is a bit of a chicken and egg type problem. In order to get to serious scale, you need serious scale applications and use cases. And both of those things are kind of being developed in tandem, which kind of is a bit challenging, especially when it comes to sort of the investments and commitments that you need and to sort of make really large scale investments. You know, we want to start to see companies committing to a 20-year PPA type of, you know, agreement, but we're not there yet. The applications are still yet to be really commercialized at scale for some, you know, there are some applications out there that are very well developed, but at the same time, there is a lot of investment required in order to, say, retrofit or to fit out large types of trucks and things like that. But then also there's the distribution network that's required. And I think that is a really material challenge. And I think it is a bit early to call how it's going to become successful. Like, you know, if you look at any cost is really important. The cheapest way to get hydrogen around is through pipes, but that's fairly expensive infrastructure. Most of our pipe network isn't suitable for hydrogen, so it will need, you know, its own infrastructure to be developed, which again is just adding to that cost stack. And at the same time, you have alternatives that are being, you know, like batteries, you know, becoming ever increasingly cheaper as well. And you're going to have the similar types of step changes in costs in the battery space as you do in the hydrogen space. And then so for certain applications, what will win at various different points in time. So the long answer is, and everyone on this call will know, is that it's complicated. But, you know, there are lots of applications that have huge amounts of potential. And I think it's really good that we're seeing support from government to develop, you know, a hub network makes sense, like to have, you know, hub generation, you know, creating the hydrogen and being used all in a fairly co-located sort of way is something that seems quite sensible to me, because it gets around that cost of distribution problem. But that is a sort of different approach to what we've had previously, and is a different type of export opportunity.
And Andrew, I want to come to you on that question about export. You know, you mentioned that there are a number of different approaches to the problem. You've got a couple of different projects that sort of have those different approaches. One of the big conversations that certainly happens in the investment space that Sybil's alluded to is the question of how do you compose that system, and is it primarily, as we often imagine in this part of the world, about export and about selling up to Asia and producing en masse, or is it more about use and distributed use, producing in distributed systems and then utilising, you know, at a local level? Do you have a view on the likely development trajectory with respect to the, you know, giant export market or really distributed market? Is that a frame that you guys think about the issue in, or do you have a different way of conceptualizing it?
No, we certainly look at it that way, and I think the answer is both. To be honest, hydrogen is this natural distributed model. It's a democratized model. What Dan's doing in creating the hubs, we're doing exactly that. So everywhere we go, every station we build, these first stations, they all have production. They are the hubs. We're creating the hubs, and we're placing them at hub fleet locations, but those locations are also part of a network. So they're part of a network node as well. So it's a hub that is a network. So I think Sybil used the term, a hub of networks, right? Sorry, a network of hubs. So to start with, we think that that model absolutely exists. And what we analyze very closely, because we've been planning this, are we doing big central production and distributing, or are we doing distributed production? And the answer is both. And the trade-off will change over time. The trade-off changes with distance and applications and what the size of the market is, because my tipping points are on-site production, what my grid location is, what quality is my local resource of renewable energy versus a large, say large-scale wind farm. So the answer is both, and understanding where they happen first is really, and how they might happen over time is important. It's really also important, I think, too. We went to the market, but we worked out we're a market-driven company. What does a market want? Where is my market? The conventional, I come from oil and gas. The conventional natural behaviour of the big oil and gas companies was, we know LNG export, we know oil and gas export. Let's just go big. Let's do what we know before. And in fact, one of the problems is that the market is incredibly nascent. It's nascent in a domestic application where we've already got tools, buses, trucks, and so on that we can use. But let alone what we're trying to do with creating these international markets. So there's one of the things we've identified and working with our partners very closely that are in fact buyers of, you know, international traders, the likes of Mitsui and so on, is now we need to build these domestic applications. We need to build those networks and those markets and work through the domestic markets, create the capability, then get the energy. It's a market-driven, not an energy-driven play. And then we scale and grow, and that export option will be there. And the whole time in our projects, already our first project in the wind farm to ammonia, we will have ammonia, green ammonia to pilot export with as an outcome of that. So it's kind of, we can start that journey, but that's not what's driving the economics of our projects.
Dan, I mean, I'm interested in hearing your views on that, on that sort of composition issue as well, particularly with respect to trucks, right? Because a lot of what you're focusing on at the moment is that really heavy transport space, and often in quite, you know, distributed applications. How do you guys approach the question of what's the best composition, I guess, for the system?
Definitely, yeah. So I think a lot of what you're going to hear in this panel, unfortunately, is actually Andrew and I mirroring each other in a lot of our answers, because it seems like we're taking a very similar approach. So
it's totally fine. Sybil and I usually do that on panels as well. We're in good company.
We might find
serious agreement.
We, you know, at Xenogen, we're a lean startup essentially, and we're trying to get as big as possible, certainly as quick as possible, but we need to do that, or the way that we work is kind of risk-free or risk minimized. And so you will see some groups, I suppose, first of all, so we always go, as Andrew was saying, into industries where we have a customer, where we'll have someone, you know, take off the gas. We won't install any infrastructure if we know that that infrastructure is not going to pay for itself. And that means having enough trucks on the road to draw down on the fuel. So a lot of people that you'll see jumping into export are either going to be people that know their own global fueling requirements and they are essentially getting prepared for it and investing very big, or you'll see a lot of private equity or investment or speculative cash saying we need to be first movers in what's going to be a burgeoning market, so let's quickly start ramping up production, install the assets and make it available. The problem with that is they're hoping for a buyer. And whilst we definitely believe in the hydrogen future, and we know that in the future there will be a buyer, it's the same as what's happened in essentially, the installation of renewables en masse, solar panels and wind turbines. It eventually became a race to the bottom where there were significant stranded assets because the people that were installing the assets were speculators and investors, and they weren't necessarily people that needed the energy or had plans to use it. And so I think, we definitely will get to the export market when we're big enough, but we'll probably get to the export market when, we have buyers of our hydrogen at that scale. And in the midterm, we're definitely going to be occupied just, we couldn't put down electrolyzers fast enough just to supply what's going to be the requirement in heavy transport. Our model is slightly different to Andrew, so we're definitely going with the hub model first. Australia is a lot larger than New Zealand, as Andrew was alluding to, although there is a reasonably good concentration along, the road corridors, Sydney, Melbourne, Brisbane. But that said, because of our specialty applications, we don't really need to leverage a network effect. As one of our commenters here, Jeff Andrews, hit the nail on the head. He said, that hydrogen trucks typically have a back-to-base or a depot-oriented model. And whilst we continue to deploy trucks in, mining, cement mixing, specialty road vehicles, most of them are going to rely on a depot or a back-to-base hub-centric model. And so I suppose we're kind of lucky because it means we can be a little bit leaner. If you have to invest in generating a network, you typically have, you lead in with an overcapacity. And you're always building overcapacity into your network because you've got to account for growth. And it's a nice thing to be able to do if you've got the cash to spend, but we're just a little bit at this stage.
Yeah. I want to come both to Andrew and Civil about that question of, you mentioned before, Andrew, the building a network and the challenges that sort of come with that solving that chicken and egg problem in a moment. But before we get there, Dan, I want to ask a little bit more about the heavy transport application because, we have these funny conversations where we, firstly, obviously hydrogen is viable in some areas already decisively and not in others. Yep. And we have these funny conversations where we talk to our global analysts and some of them say things that we don't anticipate, like, forklift trucks are already totally viable. A third of the forklift trucks in the US are already hydrogen fuel cell trucks or whatever. And we're just kind of like, wow, that's interesting. We didn't know it had run that hard in heavy transport already. So I'm interested in knowing, when you're looking at a hydrogen truck for the applications you're looking at versus a diesel truck, how does the range of performance and the cost change across those options? Because it is really the down home central of that hydrogen proposition.
Definitely. And so first of all, we'll just separate off forklifts from heavy transport because typically people who invest in hydrogen forklifts over battery electric forklifts are doing it for environmental reasons. So, and when I mean operating conditions, so batteries really suffer in high temperature, they suffer in cold. So if you're operating your forklifts in a refrigerated cold store, even a very large one, your battery performance is going to suffer. And so you'll see a lot of specialty forklifts are going to be hydrogen. But also you do get the traditional benefits of operating a hydrogen vehicle like super fast refueling. If you want to fill up a hydrogen forklift, it's a couple of minutes and it's back in the warehouse. Whereas if you're operating battery electric forklifts or any other vehicle, you've got to park them for hours. And so in hydrogen, in heavy trucks rather, or in transport or mobility, it really comes down to the energy density of the fuel that we're using. And diesel is reasonably energy dense. It's a liquid and it's combustible, gives us a lot of energy when it combusts. Batteries are solid and they're very large and they're not very energy dense. And unfortunately, hydrogen on vehicles is a gas. and that's obviously not super dense, but it's more dense than batteries. And so if you're orienting your solution around maximizing range and maximizing performance whilst minimizing the weight of the energy store on your vehicle, you'll choose hydrogen. In passenger vehicles and small cars and things that deliver light loads, it's not so much of an issue because you probably have weight to spare, and so you can put a larger, heavier battery on a vehicle that's designed to carry light loads, and it'll be okay. But if you're trying to maximize your load carrying capacity, for example, to put a battery on one of the garbage trucks, our 20-ton garbage trucks that we're looking to hit the road, you know, the battery pack is going to be between 5 and 6 tons of that vehicle's mass, whereas a hydrogen solution is going to be less than a quarter of that, so 1.5 tons of weight on the vehicle. The truck itself only has a 5 or 6 ton cargo carrying capacity, and so you know you're going to be engineering vehicles that have batteries as large as essentially their viable loads. And so there are people developing battery electric garbage trucks, but they're going to be fringe and niche. You'll see things like garbage trucks and heavy vehicles. Most of them will go hydrogen for sure.
That's interesting. And there is a question here about, you know, bus fleets.
Yeah, so it's interesting actually. So we do have, or I've seen proposals in the market. I won't name any names. People can go and do their own research, but there have been proposals by Australian businesses to launch hydrogen fuel cell augmented electric buses. And we definitely think that's a fantastic application, although, you know, it's the same problem. In a bus is quite a large vehicle, and the human cargo on those buses is relatively light, actually. So buses can afford reasonably to have large batteries on them. And you'll see in leading markets, or markets that have gone, you know, all in the electrification of heavy transport, you'll see that the penetration of battery buses is very high, and they operate really well. And we're talking about in China, where they have tens of thousands of, you know, EV battery electric buses on the road. And it does demonstrate that there's less of a business case in buses versus, say, refrigerated logistics or, you know, other, you know, transport.
It's we have a tendency to think about hydrogen, particularly I think when certainly when we started a year ago, as all one thing, but it's actually, you know, a fuel source that has very different properties and interactions and commercial viabilities at all different points in the system.
Definitely. Look, that said, you know, we were actually approached by a group in South America, and they were saying that their bus routes typically have far longer routes and limited opportunities for recharging, and they were going to be forced to go down the hydrogen route just because of their operating conditions. So it's, you know, horses for courses, but yeah, buses is you know, could go either way, whereas in heavy transport, it's more certain to go hydrogen.
So Andrew, I want to come to you on this heavy transport piece again. You mentioned before refueling networks, and having, you know, had a lot of conversations with people about electric vehicles and various other parts of the transition. My ears pricked up, particularly because New Zealand has been a leader on the EV charging front as well. And so I'm interested in hearing more about how are you finding the process of setting up those networks and working into those networks? How easy is it? How hard is it? Is it something that people naturally get as a needed piece of infrastructure? Is it an easy conversation, or is it a bit difficult to get people moving?
Yeah, good question. So one of the things that we identified, this sort of decentralization play also as an opportunity for democratization. So there's gaining that ownership across the regions. We always said it's not just about the big cities in New Zealand, it's actually unlocking the regions, because each of them have their hubs, they have their applications that we can build and create kernels. And so going and working with the regions to get their buy-in, and in fact we have a joint venture model at a number of our locations that we're actually 50-50 with local investors and councils and so on to create that ownership of that hub. and that gets a huge amount of traction. There's always this discussion that Dan just took us through about, you know, the application, where it's battery, where it's hydrogen. We even see, just to supplement the bus discussion, there's a lot of traction now around mixed fleets, because batteries run into a limitation of the charging infrastructure, just a sheer amount of infrastructure you need to charge an active fleet, and then an upper end of the fleet that tends to go the greater kilometre, say over 300 kilometres, has a real application. Otherwise, you need multiple buses. So mixed fleet model is actually being heavily considered by our partners on our fleets. So what we've done, though, is offered I'm going to turn my computer on. It was just about to go flat. What we've offered, though, is an ability to crack for the councils. At the moment, the world's relied on the councils sort of picking up and carrying that load, but the commercial sector's there, and one truck just uses so much fuel that we can underpin our stations with just these first stations. And we're very much, as Dan mentioned, you know, that the overinvestment's always a concern. So it's always shaping our production capacity to just stay ahead of the market and be efficient, to have some capital efficiency. But we can do that very easy with a very few trucks. And then that unlocks and lowers the barrier for the councils to come in. Rather than the ratepayer to pick this tab up, actually we can get the broader industry to pick this tab up. So that's the first thing. Finally, I think that the battery electric vehicle debate is one that we often run into, and it's a constant thing. And I think Dan's articulated it fairly well, that there are applications where you have this natural strength. Those natural strengths are not going away. No matter how much batteries get cheaper and better, you shift the problem. Batteries have got a problem that when you go big, there's a weight, there's a charging. If you go really quick and really light, it hasn't solved the fact that one charging of one truck is over 2,000 homes just for one truck charge in terms of the grid requirements. So you're shifting that problem. So that's just simply not going to be the application for that technology. But for cars and garages and car parks during the day, it's a wonderful application. So we end up in this, the debate is constant, and at the end of the day, hydrogen's taken longer to get out there, but it's in a bigger way on the heavier transport. And so our job is actually to get out there. The technology's been demonstrated elsewhere. Now our job is to create that, show that is a commercially viable play, and that's the sector that has the most benefit and bang for our buck and bang for the climate.
And Sybil, that's an easy question, isn't it? I'm going to come to you. How good. But I mean, you work across a lot of different issues. Hydrogen is one of them, but conversations across CCS, all sorts of transition technologies, across transitions in other spaces, across large industrial and economic transitions. Often you see this question about who invests first, who is responsible for the innovation, how do you get around the chicken and egg problems. I mean, when you think about this compared to other transitions like electric vehicles or autonomous vehicles or decarbonised steel, how do you think this is likely to play out in terms of who is the central fulcrum of making investments or getting the thing moving early?
I think there is, as you were saying, like with electric vehicles, like with renewables, there is a place for government assistance at this stage in order to support and help build out these use cases. It doesn't have to be there forever, but I do think that, there is a huge amount of, there's a huge number of applications in this space. There is a whole bunch of supporting infrastructure that needs to be put in place, whether, your example with an electric truck the equivalent of 20,000 houses, was that what's of power? 2,000, sorry. But at the same time, if we are creating green hydrogen, we need that equivalent of generation to create the hydrogen in and of itself. So, it's not an either or situation. The energy has to come from somewhere. It needs to come from green renewable sources in order for it to be truly green. I personally think CCS is something that we need to do more in, but do I think I think we've got probably better alternatives for the creation of hydrogen as renewables become ever and more increasingly cheaper. So I think the short answer is we want to see companies decarbonise, especially heavy carbon emitters and companies that are involved in the hydrocarbon sort of stack. Hydrogen is an opportunity for those companies that do have the expertise in engineering and chemicals and all of those sorts of things that sort of has some nice synergies. So we would see that it's important for them to transition, and this is a way that they can transition. Will all of them be successful? I don't know. But then I'd also say that there is an importance and role for governments to encourage and support that, whether or not it's through, if we could one day get some clear targets in place to tell us where we're going to get to. You know, got to raise it.
Zoe's having a heart attack in the background. It's hot targets.
If we can set them, anyone can. But these are all, the world has agreed that this is where it needs to get to. And so everyone needs to help us get there. And this is an opportunity for those companies that who have most benefited from carbon intensity in the past to kind of help facilitate that transition.
I'm going to come to a little bit more of those conversations potentially about policy and some of the innovation difficulties you touched on, Andrew, earlier in a moment. But there are a few questions that come up about hydrogen over and over again that are sort of coming through the chat. And so I thought that I would refer them to the panel at large. And the first one that I might start off with is, well, the three are blue versus green, which is a conversation we have in Australia, but potentially not as much in other regions. Is there an upper limit of feasible production of green hydrogen? And water? You know, what do we do about water in a country where we don't have much of it? So if I start with blue versus green, there's an argument that gets made by lots of people that we've got to have blue because it helps us get to green. Does anyone on the panel want to respond to that argument? And has anyone got strong views? Andrew, you first.
Andrew, go first, yeah.
Yeah, I guess firstly, one thing, Sybil, just to clarify, I was talking about the grid capacity needed to charge the vehicle. It's very different from the amount of energy. So it's a grid capacity, and that's one of the problems with large-scale heavy vehicle charging, is the grid capacity is so extreme to have commercial charging times. So just it's a very important differentiation. No, so blue, I guess I come from an oil and gas background. I spent 22 years working out how to efficiently extract oil and gas out of the ground. I also know how expensive it is to drill wells. I used to run the wells departments of major oil and gas companies, and it is expensive. And one of the things that we need to be very careful when we talk things like blue and brown and so on is there's the existing hydrogen market and the existing hydrogen production that exists in steam methane reformers and so on. We are talking about a transitional shift away from liquid hydrocarbons, for example. That is new market. So we need to be very careful. There's potentially disingenuity here about talking of blue hydrogen being a pathway when actually there's very, very little blue hydrogen projects in the world, and we are talking about creating new hydrogen production. If you have to build a steam methane reformer and the wells in the ground, or find an injection pathway for the wells in the ground, even in the existing assets, that is a very different story from going and saying that, you know, it's already there and therefore blue. So one of the things we need to be very careful, because all that will do is slow down the investments that are necessary in green. We're absolutely passionate about that. Green will by far and away be far cheaper than any blue project will be, but we need to invest now and drive that scale up and the costs down. So the enabling argument, when you actually, the other really important thing when we talk blue and green and so on, particularly for transport, and Dan will recognize this as well, is that if you're making blue or brown, you're making it on top of a large field or near some resource, which isn't at your market. You need to convert that hydrogen into you need to clean it up once you've turned it into hydrogen, you've got to compress it, you've got to get it to your market, you've got to put it into more compression to put it into a vehicle. By the time you've done that, your difference between even brown and green might be $17 versus $15. That is not enough, let alone if you take the blue version, right? So I think we need to be really, really careful with that argument. It's an argument based on a resource thinking. It doesn't mean that there isn't a huge role, though. I just want to be, there is a huge role for blue in decarbonising where we use natural gas now. So taking blue hydrogen and getting the CO2 capture and transitioning our grids and doing all that, I think that's a really interesting proposition and should be looked at, but it can't get in the way of investments in green.
Dan?
I agree with Andrew. So essentially, all of our innovation and investment into scale is going to be scaling around green. We're a little more pragmatic. We do see blue as a stepping stone. And that's because specifically in our sector, in refuse collection, we do have access to biomethane type resources. And so it's blue, but it's a little bit different. It's kind of blue-green, if you will.
I call that green. That's green.
Okay. So, a lot of people believe green is, electrolyzer from a renewable source somewhere, but we will also take, biomethane or something like that. Yeah, I agree. There are definitely pathways to scale where green will be as cheap as blue, if not, or brown, if not cheaper in the long run, especially in countries like Australia where, the price of renewable electricity is going through the floor. And then it just comes down to how cheaply can we make our production infrastructure and how cheaply can we distribute the gas to wherever it's needed. Because the principal cost of electrolysis is the electricity that goes in. And the infrastructure over a long period of time. And so Xenogen's, core business, if not anything else, will be getting the cost of infrastructure down.
There have been a few, Dan, I'm going to go with you because you're sort of in the process of already answering. And then if anyone else wants to jump in on this one, do feel free to. The question of water is obviously coming up quite a little bit in the chat. It comes up on every conversation that we have about green hydrogen, electrolyzer produced hydrogen in Australia. Is it something that features strongly in the considerations that you have to make? I mean, we get very varied information about that. It sort of seems to be a really big deal for some people and not so much on the radar in other cases.
Yeah, so look, I do understand the consideration, and I know that, comments in this space can be really inflammatory. So I'm not going to throw any grenades into the people that really do think that water is going to be a limitation. And so I'll talk about it in our specific context. We are developing hydrogen generation assets for local governments around municipal waste collection. And wherever we are operating, there is a readily available, supply of water, and it's not going to impact the local community by taking the water that we need to make hydrogen for those fleets. It's also, a lot of people think that solar panels, exist in a desert and there's no water where there are solar panels and there's no water where there are renewable generation assets. But we forget that, in Tasmania, it's principally powered by, hydroelectric system. In southeastern Australia, we're also principally powered by hydroelectric. There's a lot of wind around as well. There's the potential for ocean power. So we just need to decouple this kind of idea of putting solar panels in a dry desert and electrolyzers in a dry desert. There are a far greater number of opportunities where there is water. And worst case scenario, just from the energy cost perspective, there are people talking about making hydrogen from salt water. It's a more energy intensive process and it requires, better cleaning and purification and that kind of stuff, which all adds to the cost. But in a future where this kind of technology starts to become mature, if we do end up encountering a barrier, which is access to water, then I'm sure that's going to become a viable option as long as it's managed appropriately as well.
Sybil, can I throw to you? I mean, you've had some of these conversations both about green versus blue and also about water at a sort of high full system level. Are there any points that you would add to those debates from the conversations that you've had?
I don't really have much to to add, just to sort of say that, you know, if a lot of these it's not like what we're replacing has no impact. So, you know, there is a lot of water required in, I think someone raised the point in the chat, in mining, and if we can better manage our resources, then the impacts might not necessarily be as great. That's not to say it's not something that we need to consider. It's just, it is a factor, and it's, you know, it is definitely something we need to be cognizant of, and will limit the places where you can potentially have these hubs potentially. But that's, sorry, Daniel.
I was just going to say, it occurred to me as well, it's not like we're locking up the water for a very long period of time anyway. Yeah. So as soon as we turn the water into hydrogen, we're not planning to store it particularly long. You know, it's almost generated on demand. There's a little bit of buffer storage. It goes into the vehicle, and then the vehicle consumes it, and it literally turns back into water at the place essentially it was generated. So it's not like we're tying it up as well. Sorry, that was a thought. You can...
Yeah, well, I was actually going to sort of, it's also like the wider benefits that you get from this, it's potentially a greater good. And as Daniel was saying, if your output when you're using it is water, then that's much better than your output when you're using it is all of the other things that come out of diesel trucks.
Lots and lots of lovely stuff that comes out of diesel trucks.
Yes.
As we all know. Andrew, I want to come to you, and let's move in a moment to have this sort of conversation about what are the big challenges we've got going forward, because we've got 9 minutes left. But Andrew, I want to ask you, one of the conversations that we have a lot in, particularly when we speak to analysts in Europe, is about, can we put enough energy together to make this happen? Sybil mentioned earlier, you know, this is not a single point problem. You know, there's a whole system build that happens when you're trying to get particularly green hydrogen running. Do you see any sort of upper limit with respect to how much green hydrogen is produced, or how much of, you know, let's say heavy transport demand can be facilitated by green hydrogen? I was looking at the IEA projections yesterday afternoon actually, and I think they've got something like 60% of heavy transport by 2050 or something along those lines. But when you look at it just mechanically, do you see any boundaries there?
No, to be honest, one of the things that we're finding, and it's already happening with our own projects, is that hydrogen enables renewable energy projects because of the way it captures the energy. This is the fundamental. I think there was a question or the mention, so energy return on investment is often used, or energy efficiency. Those are very, very one-dimensional analyses. They're very short in that they don't take into account time and place. So when energy is generated in a different place, when it's generated at a different time, that has a different value. And so there's a factor here that hydrogen can capture so much better than other technologies, and that starts to enable those renewables. So yes, you need a lot of renewables to do green hydrogen. There's a limit of, and I'm quite passionate, I think biogas is a very green geosphere story. There's a limit though of the biogas story before you start to butt into food production, you know, other areas. But renewables to feed the hydrogen requirements is imminently doable, and it's about, there's a lot even of hydrogen that comes from the existing installed excess energies that they're seeing through curtailments and so on. But no, to me, it's a hand-in-hand development. We're the very fact that we get so much interest from renewable developers to couple with our hydrogen projects to create and underpin more renewables. We've done the numbers and then the degrees of gigawatt. It is not at all out of. It's not at all out of the wild realms to produce what we need to. The challenge is where. So Australia and New Zealand are in a wonderful position for this. Other parts of the world with higher levels of renewable energy are in a wonderful position, but there are other areas that aren't. That's why there's the export discussion, is because not everyone can produce those volumes. But we have far in excess of capacity in New Zealand, and we can certainly see a line of sight to the volumes we need. And likewise, you know, Australia's renewable potential is just enormous. So, but we're lucky. we're lucky. So globally, that is where the export will have to come in if we're going to decarbonise on scale.
Mm. So, team, we're sort of starting to come towards the end of our conversation, but one of the things that I'd be interested in hearing from each of you is just when you look at this, and you'll have different views on this because you're operating at different levels, but when you look at this as a proposition that is, let's say, particularly green hydrogen, heavy transport and export in specialist industrial applications, as a significant decarbonisation pathway. When we look at that proposition, what would you identify as being the things that we'll have to get right in the next 10 years, or the big levers that might need to be in place? That might be policy, it might be investment, it might be getting the demand in place. You know, what jumps out at you as being, you know, the things that you anticipate needing to go right in the space? I might start with you, Andrew.
I think it's really important that we don't have the false starts and chase down sort of white elephant projects just to sort of try and make a point or go with the herd. So I think careful planning and diligence in the project planning and the investments is to really make sure it is, because this is commercialization. This is not technology invention and development. So that I think clear, good, sound commercials is incredibly important, would be the first thing I would say, and we need to get that right. Policy, we've already heard that the things that will enable that are these other elements, but at the end of the day, I'd say the most important thing is that a clear pathway, a commercial approach.
Dan, do you want to add to that?
Yeah, sure. Look, policy is definitely zigzagging, but it's generally tracking in the right direction. The federal government and the agencies they've deployed have been very supportive to demonstration projects. They're obviously doing their best to find the right ones, and so we don't really see them prolifically, you know, hitting the ground or being commissioned, but they are choosing good ones here and there. And, you know, we hope to be one as well. We are a little bit leaner and we're very commercially oriented, and so we don't really want to be impacted by policy or by subsidies or by anything other truly than market forces. And so all of the levers that we're aiming to pull are ones that help us get to, you know, a parity total cost of ownership with diesel operations. And once we get there, the market will kind of start doing its own thing. And so, you know, it's still actually technology innovation. It's getting the cost of the vehicles themselves down. That has to be borne by people bigger than us. It's going to be the OEMs and the investors in those technologies, and they're doing a good job with that. So that's fantastic. Our piece is going to be around scaling manufacturing and distribution. And so, you know, we need to be able to do that efficiently, and we will seek support to do that. But that's not just around launching a clean green technology. That's also, you know, Jobs for Australia, who wants to position, you know, electrolyzer manufacturing or distribution equipment manufacturing or truck assembly in their local government or region or state. And so we'll start to see those kinds of decisions, jobs, technology, growth, actually driving the deployment of this more than probably the clean green debate at this stage.
Mm. And do you, I mean, just before I go to Sybil on this point, do you feel like a lot of that conversation is about scale, you know, getting the technology where it needs to be and then sort of scaling. Do you feel like you've got the demand pathway to scale at the moment? Is it a matter of kind of getting the ducks in a row, getting the investment and just putting the pedal down? Does it look like there's the demand gateway there?
If it's okay, Dan, I'm sure you got something to answer. I guess something that I'd like to just point out, this is a very important point. We've seen a huge shift in that. So one of the things, it's the boardrooms of the major companies have started to look at they're reporting their emissions, and they're starting to go, crikey, you know, I've got all these emissions and there's only a few places I can actually tackle. And so the market is a latent market waiting to go. We just need to create that scale on the infrastructure to get the cost down of the hydrogen, and the scale of the vehicle manufacturing to get the cost down there, and the two come together. So I guess to probably mirror what Dan's saying. Those two ends, our role is what we've had to do, and I know Dan's had to do, is we've had to create that chicken end and bring both of those ends together. But it's now over to the bigger sector to really ramp up that scale, and with a little bit of a push right at the start from government, both in New Zealand and Australia, I think it's absolutely doable.
Agreed.
And do you have stuff to add to that before I go to Sybil?
No, I really don't, to be honest. I mean, carbon pricing was fantastic to influence boardroom decisions, but, you know, without carbon pricing, the boardrooms are still, you know, taking that corporate social responsibility position very seriously. And we're getting a lot of people approach us today saying, very simply, we're emitting a lot and would like to do something about it. And they're not being beaten with a stick. They're definitely doing it because they want to. So
that's good. That's a relief.
It's a relief.
Sybil, lucky last, you know, when you think about what you might not like to see go right in the next 10 years on this, or what would be decisive, what would you volunteer?
I just would probably emphasise, and it's kind of been said here, is that we can't wait for perfect, and we can't wait for a single solution, and we've just got to we should start with what works, which is what, you know, Dan's clearly articulated, and as has Andrew. We can start with what works and then work towards the stuff that's harder, but we've got to start moving now. And, you know, talking about multimodal, you know, using the fuel that's fit for purpose. We're not necessarily, like we're seeing in our energy systems, we're not going to get a one-size-fits-all solution. We need to use the tools that we have available to us now. If there are avenues where it's commercial, that's where we should start. We shouldn't wait for, you know, be solely focused on using hydrogen for steel production now, because that's still got to be built out. But we can, where we can use hydrogen in these in heavy trucks and those sorts of things, and if that works and we can do it, produce it locally, you know, that's the sort of stuff that we should start to do now, because we can. So what I've been really pleased to see, especially in this last year, is that, you know, there has been a shift change in the conversations that we're having with corporates. And I think the willingness to try to start now rather than wait for perfection. It might be a bit more expensive now, but at least we can build the skills in a smaller scale and then build it out, has come a long way. So that's kind of what I want to hopefully continue to see, because I know we are seeing a lot more of it now.
Excellent. I mean, I think that's a really good place to end, because we are going through this process where we've talked a lot about transition, we've talked a lot about the right technologies and a lot about the technical feasibility, and now it really is about getting to the point where we'll give it a go. And I think a lot of people have been giving it a go for quite a while, including everyone in this panel, and some of us might have a bit of a headache because we've been giving it a go for a while and getting a bit tired of banging our heads against walls. But it is really excellent to sort of hear that from a number of different angles, that corporate interest and that, I guess I could say, the interest of the big end of town is really picking up. So obviously quite a long way, a long road to still go on hydrogen, and a road that may go in many directions, and I'm sure many people will go in many directions, but a very exciting space. And Andrew and Dan will be Sybil and I will be watching with much interest in conservative, large institutional way. I think.
Write us some checks along the way, Zoe.
Yeah.
We just heard from Sybil. That's a ways off.
we're not in sport. We're not in private equity land.
Okay, we can structure investments any way you need to.
With that,
we'll encourage our larger investment to partner. No.
I'm taking these guys backstage. Thank you, everyone who has joined us.
Thank you.
And we hope you'll join us again for future EnergyLab discussions. Bye, everyone.
Bye. Thanks, Zoe.
Adam, take us backstage.